So we'll see the first concept. So what is speed, how to calculate speed, or how to calculate time taken and distance covered. So what is speed? So speed is a distance covered by a person in 1 hour. So if it is in kilometer per hour, distance covered in 1 hour. So if it is in meter per second, distance covered by the person in meters in 1 second. Say for example, so if a person covers 400 kilometers in 8 hours. So here distance covered is 400 kilometers in 8 hours. So now what is the corresponding distance covered by this person in 1 hour? So if he is able to cover 400 in 8 hours, so what will be the distance covered in 1 hour? So by calculating this, so we cross multiply. So because this varies, kilometer distance and hours varies directly, cross products will be same. So dividing this 400 by 8, we get 50. So the person covers 50 kilometers per hour. So this is the speed taken. So speed is nothing but distance covered by a person in 1 hour. So speed is calculated by, so distance covered by time taken. So by dividing the distance covered by time taken, we get the distance covered by the person in 1 hour. So speed is calculated. Suppose if time is asked, so dividing the distance by speed, so we get his travel time. And the same way, if distance is asked, so we'll multiply the speed and time taken. Say if speed of a person is 10 km per hour, and with this speed he travels for 3 hours. So what will be the distance covered by him? Per hour 10 kilometers. So for 3 hours, multiplying this 10 and 3 at speed into time, so we get the distance covered is 30 kilometers. So now using this concept, we will see a small example, a simple example. So the example question is, a person travels 200 kilometers in 4 hours on day 1. So next day, he travels the same distance in 5 hours. So what is the ratio of speeds taken in both the days? So we will see how to find the speed and then the ratio of speeds. So the first day, so to calculate the speed, so we know that it is the distance covered by time taken. So distance covered here is 200 kilometers, and he covers this distance in 4 hours. So here what is the speed taken? Dividing the distance by time, so we get as 50. So speed here is 50 kilometers per hour. So on the second day, so to calculate the speed, the same distance is covered with different timing. So here distance is 200 and time taken is 5 hours. So dividing this, we get 40 kilometers is covered per hour. So speed is 40 kilometers per hour. So now to get the ratio of speeds, so the first day speed is 50 and the second day speed is 40. So by simplifying, so the ratio of 5:4. So it's very simple to calculate, and though it is a simple concept, so they ask questions based on this concept. So here speed is got by distance by time taken. So both days speed is calculated and the ratio is found. So speed is calculated by distance by time taken. So on day 1 the speed is 50 kilometers per hour, that is distance by time, 200 by 4. On the second day speed is distance by time, that is 200 by 5, 40 kilometers per hour. So ratio of speed is 5:4. So it's a simple concept, but it is an important concept. So now we'll see what are the inverse and direct variation concepts related to speed, time and distance. So the variable speed and time so varies inversely. So that is speed is proportional to reciprocal of time taken. Say suppose two moving bodies, A takes 4 hours to reach a place, and suppose B takes 6 hours to reach a place. So here A takes 4 hours and B takes 6 hours. So to cover the same distance, so who has taken more time? B has taken more time. So whose speed is more? So obviously the person who has taken less time, speed is more. So here A takes 4 hours and B takes 6 hours. So as A is taking less time, his speed is more. So speed and time varies inversely. So based on this concept, we'll see how to work out questions. So now we'll see this example. The question, walking by 5/7 of the usual speed, a person is 12 minutes late. What is the usual time taken? So in this question when you check, his speed has become 5/7 of usual speed. Suppose if he was walking with the speed 7 kilometers per hour, now his speed has become 5 parts, 5 kilometers per hour. So as his speed has been reduced, he takes more time to reach a place. So because of that, he is 12 minutes late. So on this concept, so you are asked to find what is the usual time taken. So we'll see the working. So here time taken fraction is 5/7 of usual speed. So when he was taking 7 parts, now he is taking, so present speed is 5 parts. So we'll write the ratio of speed, so that is present is to usual. So usual is the original speed he was taking, and present is the speed which is taken, he is taking now. So speed ratio they have given 5/7. So the base is 7 part. So we'll write in the second part 7. So usual speed 7 parts and the present speed is 5 parts. So we saw the speed and time varies inversely, and when writing we need time taken, usual time. So we need time taken ratio, which is the inverse ratio for speed. So inverting the parts we get the inverse ratio. Whenever you have two values, two parts, just invert the parts to get the inverse ratio. So time taken ratio will be 7:5. So when speed ratio was 5:7, time taken ratio is 7:5, and they have given 12 minutes late. So whenever they give late or early, it is difference in time taken. So in this question, so it is given that 12 minutes late. So difference between the present time and the usual time is 12 minutes, and we'll check what is the difference in parts. So here difference in parts is 2 parts. So 7 minus 5, we have 2 parts. Say for example, you have a ratio like 3:7. So what will be difference in parts? 4. So 4 parts according to our question will be 12. So but here we have 7 and 5, difference is 2. 2 parts is 12. So then what will be value of 1 part? So dividing by 2 you get 6 minutes. So 1 part is 6 minutes, and we need the usual time. So usual time is 5 parts. So multiplying 6 with 5 you get the usual time taken. So time taken is 5 parts. So 5 into value of 1 part is 6. So 5 into 6, 30. So usual time taken is 30 minutes. Suppose if they ask what is the present time taken, so that is we need 7 parts. So 7 parts will be 7 into 6, 42 minutes. So when you check here, difference between the usual time and the present time is 12 minutes. So we have got the usual time using this variation concept. Speed and time varies inversely. So here the working is, as it is given as late, difference between present time and usual time is, that is 7 minus 5 is 2. So 2 parts is 12 minutes and we need 5 parts, that is the usual time. So 5 into 6, 30 minutes is the answer. So we'll see another example based on this concept. And the example is, a train starts at 8 a.m. Traveling with 6/13 of its original speed, the train reaches its destination at 8:26 a.m. What is the time it would have saved with original speed? So when you check this question, so the train starts at 8 a.m. and reaches at 8:26. So here the travel time is 26 minutes. So the speed has become 6/13 of original speed. If speed was 13 parts, now it has become 6 parts. So now based on this, as did earlier in the previous example, so we can find the usual time. So but here check the question is not the usual time. So you are asked to find the time it would have saved with the original speed. So we'll see how to find the usual time and then how to find the time it would have saved. So we'll see the working. So the train starts at 8 a.m. and it reaches at 8:26. It means the travel time, that is time taken, is 26 minutes. So that is the present time is 26 minutes. And the speed is 6/13 of the original speed. So as did earlier, we'll write the present and the usual speed taken and then we'll find the time taken ratio. So present is to usual details. So here speed is given. So speed is 6/13 of the original speed. So earlier it was 13 parts. Now it is 6 parts. So speed has reduced. It means that time taken is more. So it will take more time than the original time. So what will be time taken ratio? So it is 13:6. So earlier in the question they gave us so many minutes late, or if they give us early, we'll find difference in parts. Here the total travel time itself is 26. So it means that the present time is 26 minutes, that is 13 parts is 26 minutes. So if 13 parts is 26 minutes, so what is the factor we have multiplied to get 26? It is into 2. So we have multiplied into 2 to get this 26. The same factor is multiplied with 6. So you get as 12 minutes. So the usual travel time should be 12 minutes. That is, the train should have reached at 8:12. So but it has reached at 8:26. So now we are asked to find what is the time it would have saved. So instead of taking 12 minutes, the train has taken 26 minutes. So what is the difference in timings? So the difference in timings is 14 minutes. So it would have saved 14 minutes with the usual speed. So here the working is, we have written the ratio of present and usual speed, that is 6:13, and we need time, so write the inverse ratio 13:6. So here the travel time 26 minutes and we have got the usual time as 12 minutes. So please note the question carefully. They have asked what is the time it would have saved. So you should find the difference in timing. So 26 minus 12, it is 14 minutes. So we'll see the next example. Time taken by a person to walk to a place and ride back is 3 hours 45 minutes. So when he walks both ways, time taken is 5 hours 45 minutes. What will be the time taken when he rides both ways? So in this question, so they have given walking and riding back, he takes 3 hours 45 minutes. So when he walks both ways, so speed is less. So whenever speed is less, time will be more than walking and riding back. So 2 ways walking, he takes 5 hours 45 minutes. So you are asked to find what is the time taken when he rides both ways. So we'll see the working of this question. So here walking and riding back, as per detail, he takes 5 hours 45 minutes. So walking and riding back, he takes 3 hours 45 minutes. And both way walking, time taken is 5 hours 45 minutes. So W plus W, or you can write as 2W is equal to 5 hours 45 minutes. And the question here is, what will be time taken when he rides both ways? R plus R or 2R. So when you check here, this is the base. Walking one way and riding back, riding other way, he takes 3 hours 45 minutes. So when he walks both ways, so as both way he is walking, speed is less, time taken is more. So you need to find the time taken when he rides both ways. So you can solve this like solving a linear equation. Say you have 2W, multiplying this equation throughout, you get 2W plus 2R into this value into 2, and then when you cancel, you get time taken when he rides both ways. But instead of working all this, so just it is easier to work out if you check what is the additional time he takes when he walks both ways. So while walking he takes 5 hours 45 minutes, but walking riding he takes 3 hours. So what is the difference between these two? So from the base he had taken 2 hours more when he walks both ways. Now when you need to find time taken when he rides both ways, so you just subtract this additional time with walking and riding time. So when you subtract this, so when you subtract 2 hours from this 3 hours 45 minutes, so time taken to ride both ways is 1 hour 45 minutes. So instead of solving all this equation, just see the additional time taken when he walks both ways. So that you subtract from this base and you get, so he'll take 2 hours less when he rides both ways. So 3 minus 2, it is 1 hour 45 minutes. Say for example, suppose walking and riding, if he takes 10 hours, and if they have given the detail for two-way riding, say he takes 7 hours when he rides both ways. And if you are asked to find two-way walking, so here check what is the time he saves. So he saves 3 hours. And when they ask what is time taken to walk both ways, just add this 3 with this base. So you will get 13 hours. So instead of solving all this equation, it is very simple. So just see what is the time he saves. That will be the time which he will take more when he walks both ways. So here the working will be, and you can say this as a shortcut also. So when he walks both ways, time taken is 5 hours 45 minutes. Walking riding is 3 hours 45 minutes. He has taken 2 hours more when he walks both ways. So when he rides both ways, he will take 2 hours less. So answer is 1 hour 45 minutes. So we'll see the next concept.